Good day, mates. This is How Lee, your Quantum Odyssey tour guide, making a return. And it's official. At day 24, we're nearly halfway through the 50-day challenge, and today is May Day. Microsoft has achieved a Guinness World Record for having the most users taking an online AI lesson within 24 hours. And that means we will have to move fast. We'll have to move fast. That venture will become tougher as we venture through the outer layers of the distant solar system. Today, I will discuss about the quantum entanglement. That is the first topic, quantum entanglement. And second of all, we will discuss about the plans for the ring 2. So, entanglement, and then ring 2. So what is entanglement first of all? So entanglement is when a multi-qubit system cannot be decomposed into separate qubits. So basically, it means that two qubits, the outcomes have to be correlated in some ways. For example, when two qubits are maximally entangled, that means if you measure one qubit and you get like one particular result, you instantly know what is the state of the other qubit. So entanglement is when the state of the qubits, the states of the qubits cannot be decomposed. And their measurement probabilities can no longer be decomposed. So this is what entanglement is. We will discuss about the simplest entangled pair of qubits. So this is called the Bell state phi plus. So let's define phi plus as 0, 0 plus 1, 1, each with a radius of root 2. That means the sigil diagram would look like a half-size sigil on the very first and a half-size sigil on the very last. In this case, they can simply be achieved using a Hadamard and a CX gate. So this is how the gates would work. So we have this. This is sorry about that. Like you can also apply you also have to apply an H on the other pair because it's not a controlled gate, and controlled gates in quantum Odyssey, it has to be of the on polarity. That means when the control bit is 1 without relying on constant gates. So we have this. We have H, and then we have, this is the control would be the, so H on the last qubit 0, and then we have, let's say if 0 is on, then you switch the halves. So this is one way of achieving a Bell state of phi plus. We can also achieve another example, this time by putting the Hadamard on the first qubit and the control on the first as well. So we have this overlapping diagram over there. So H on the first, and then the CX over there. So this is how the sigils would flow. So we have H on the first, and then CX on the first and 0th. Now we have the 5 plus state. We end this session with considering other 2-qubit maximally entangled states. We have phi minus, which is of this form, except the right sigil is red. And then we have the psi plus and the psi minus, which now uses the middle two lengths. This concludes our today's rather short session. Please remember it will all be re-recorded. Good luck, everyone.